Wait.
Making do here no it get on the right of no.
Start. Greetings, everyone. Still on our topic inequality. The last class we talk about how to solve simple linear inequality. We talk about how to solve absolute value inequality. So today we will go straight to fractional inequality. In fractional inequality, we will start with less than sign, the one that goes with less than sign. Whenever you have a fractional inequality, linear fractional inequality, it is expected that you have two range of answers. That simply means with less than, our value of x will range from a certain point to a certain point. That simply means that x will be defined. The x will have some digit value that will satisfy the inequality within a particular range. Outside that range, it will not satisfy the inequality. So let's go straight and see how we solve this. Now, we are taking example 1. X plus 2 over x minus 5 less than 0 as solution. Here, for this expression to be less than 0, we have to assume let x plus 2 be what? Less than 0. So if x plus 2 is less than 0, that means that x will be less than 0 minus 2. That means x will be less than minus 2. So if x is less than minus 2, we need to test and see the validity of the value of x. If x is less than 2, will this satisfy the inequality? So let's take like minus 3 for instance, because we say x is less than minus 2, so that means x can be minus 3. If we use minus 3 to test this inequality, that means from here x will be minus 3 plus 2, making x to be minus 1. While here we'll have what? Minus 8. So minus 8 minus 1 over minus 8 will give us 1 over 8, which is what? A positive value. That means that inequality does not satisfy. This is what I mean. Test. We are testing. We say let x equals to minus 3. So that means minus 3 plus 2 all over minus 3 minus 5 less than 0. So that means minus 1 over minus 8 less than 0. So 1 over 8 less than 0 is what? False. So x cannot be less than minus 2. So since x cannot be less than minus 2, that means x can be greater than minus 2. So let's assume let x be greater than minus 2. So if x is greater than minus 2, we need to pick a value that is greater than minus 2. So we take let x equals to minus 1, because minus 1 is greater than minus 2. So from here, that means minus 1 plus 2 all over minus 1 minus 5 less than 0. So that means we have what? 1 over minus 6 less than 0, which is what? True. So because this is true, that means what? X is less than greater than minus 2 is what? Valid. So we have our first valid point. Now we take our second expression to check the same thing. So we have x minus 5 less than 0 transpose, that means x greater than 0 plus 5, that means x is what? Less than 5. So that means if x is less than 5, we are looking x to be something like 4. So let's test. So we assume x to be equals to 4 because x is less than 5. So that means 4 plus 2 all over 4 minus 5 should be less than 0 if it is correct. So that means 6 over minus 1 is less than 5. That means minus 6 is less than 0. So this is what? Valid. So we don't have to test for x is greater than 6, but you can still do that on your own. If you do that, you'll find out that it is what? Invalid. So that means that our two valid answer will be x is greater than minus 2 or x is less than 5. So to put this in a single range, that simply means minus 2 is less than x is less than 5. So that simply means within this range of x, the solution you have here will satisfy this inequality. That means x, it can be minus 1, 0, 1, 2, 3, 4. So within this set of the value, whatever you use will satisfy this inequality. I believe the example 1 is clear. Thank you. Okay. After this, looking through the first solution, now let's see alternative method. Actually, some students always prefer this method. Like I said before, that whenever you have less than, your value of x will lie between a certain range. That simply means from the least value of x to the what greatest value of x. So if you have that in mind, the test will not actually be too necessary. You can just always have in mind that your value will be between the least value of x to the what highest value of x. Now let's see how to put that into solution. Now I'm solving the same question again, but with different approach. We have x plus 2 over x minus 5 less than 0. So that means I will pick, let x plus 2 equals to 0. So that means my x will be equals to 0 minus 2, and my x will be equals to minus 2. And x minus 5 equals to 0. That means my x will be equals to 0 plus 5. So that means my x will be equals to 5. Here I have my two values for x. My x is minus 2 and my x is 5. Like I said, that your x will lie between the least and the what highest value. So that simply means my range of x that will satisfy this inequality will be minus 2 less than x less than 5, because minus 2 is my least value of x, while 5 is my what maximum value of x. And because of this sign less than without equals to, that simply means minus 2 and 5 are not inclusive in this solution. So that being said, that means that my x values taking only integer will be minus 1, 0, 1, 2, 3, 4, which still give me the same solution as my previous working. So any of these method will give you what a valid answer. Hope you find this method simpler, but whichever one you choose, as long as you understand the concept that whenever you have less than, your x will lie between a certain value of x, you can use any of the method to solve. Now let's move to example 2. Example 2, we have 2x minus 3 all over x plus 3 greater than or less than 0. Again, 2x minus 3 over x plus 3 less than 0. We are still working on the same concept of what less than. Don't forget what I said earlier, that your answer will do what lie between the least value and the what highest value. So from here we solve. So we have 2x minus 3. We said let 2x minus 3 equals to 0. So that means 2x will be equals to 0 plus 3. That means 2x will be equals to 3, and x will be equals to 3 over 2, or one whole number 1 over 2. If you like it in point or 1.5, any of the answers will be what valid. So also we say let what x plus 3 equals to 0. So our x will be equals to what minus 3. Now we ask ourselves, between minus 3 and 1.5, which is the least value of x? Of course, minus 3 is the least value of x, while 1.5 is the maximum value of x. So if we put this within range, that simply means minus 3 will be less than x and less than what 1.5. So this is what we have as our solution for this inequality. I hope this is very clear. Now let's advance to the final example. Example 3. X over x minus 5 less than 0. Still same thing, same approach, no shaking, no fear. We are still taking the same concept. We say let x plus 3 equals to 0. So our x will be equals to 0 minus 3. So our x will be equals to minus 3. And x minus 5 equals to 0. So x will be equals to 0 plus 5 and x equals to 5. Again, we have our two values for x, minus 3 and 5. Don't forget the least value always comes first before the maximum value. So the least value will be minus 3 less than x less than 5. So here give us the solution to our inequality. I hope with these three examples you can solve fractional inequality, linear fractional inequality with ace. Thank you and get set for classwork to see how much you are following so far. Thank you.